Today, the topic for our presentation is model selection criteria. In this presentation, we'll be talking about following topics. Introduction, different types of model selection criteria, R squared or adjusted R squared, Akaike information criteria or Bayesian information criteria, p-values of coefficients, residual plots, outliers, cross-validation, and conclusion. Regression analysis is a statistical technique used to examine the relationship between a dependent variable and one or more independent variables. When conducting regression analysis, it is important to select the most appropriate model to achieve the accurate and reliable results. In this presentation, we'll discuss some commonly used model selection criteria in regression analysis.
As we saw in the previous slide that there are multiple model selection criteria. Now to begin with, we will start with R squared or the adjusted R squared. Now what is the R squared? So the R squared or the adjusted R squared is the coefficient of determination, which is a statistical measure in the regression model that determines the proportion of variance in the dependent variable that can be explained by the independent variable. In other words, R squared shows us how well the data fit the model, or it helps us measure the goodness of fit. It is to be noted that the R squared takes values lying between 0 to 1. The higher the value of the R squared, the better the fit of the model. Now, however, it is important to note that a high R squared value does not necessarily mean that the model is a good predictor. R squared does not penalizes the model when we increase the number of variables. That is, it does not penalizes the model for the increase in number of regression coefficients. Thus, the adjusted R square comes into picture, which is a modification of the R squared test that accounts for the number of variables in the model. It penalizes the model in accordance to the number of regression coefficients. Now we may talk about Akaike's information criterion or the AIC. AIC is yet another model selection criterion. It implements an even harsher penalty than the R squared or the adjusted R squared. Akaike's information criterion or the AIC is a mathematical method for evaluating how well the model fits the data it was generated from. In statistics, AIC is used to compare different possible models and determine which one is the best fit for the data. AIC is calculated from the number of independent variables used to build the model and the maximum likelihood estimate of the model. That is, how well the model reproduces the data. The best fit model, according to AIC, is one that explains the greatest amount of variation using the fewest possible independent variables. It is to be noted that the formula for AIC is 2k minus 2 log function of L cap, where L cap is the maximum value of the likelihood function for the model, and k represents the number of estimated parameters in the model as you can see in the slide. Now we shall talk about p-values of coefficients. P-value of coefficients is yet another criterion that assesses the significance of each predictor variable in the model. A p-value less than 0.05 is commonly used to indicate statistical significance. P-values help to identify significant predictors that should be included in the final model. If the p-value for a variable is less than your significance value, then your sample data provides enough evidence to reject the null hypothesis for the entire population. Your data favors the hypothesis that there is a non-zero correlation. Changes in the independent variable are associated with the changes in the dependent variable at the population level. This variable is statistically significant and probably a worthwhile addition to our regression model. On the other hand, when a p-value is in regression is greater than the significance level, it indicates that there is insufficient evidence in our sample to conclude that a non-zero correlation exists in the data.
Next, we have residual plots. These plots can be used to assess the goodness of fit of the model. If the residues are randomly scattered around zero, it indicates a good fit. If there is a pattern in the residuals, it suggests that the model may not be appropriate. Outliers. It is important to identify and investigate any outliers that may be affecting the model's fit. Outliers can have a significant impact on the results of the regression analysis and may need to be removed or dealt with in some other way. Lastly, we have cross validation. This technique can be used to access the model's predictive performance on new data. The model is trained on a subset of the data and then tested on the remaining data. The process is repeated multiple times to obtain an estimate of the model's predictive performance.
When conducting regression analysis, it is important to use appropriate model selection criteria to ensure accurate and reliable results. We discussed some commonly used model selection criteria in this presentation, including R squared, AIC, BIC, p values, residual plots, outliers, and cross validation. It is important to choose the criteria that are most appropriate for the research question and interpret the results in the context of data's limitation.